Now from the previous problem, we found our theoretical yield, we found our limiting reactant. There's no way to get the actual yield without more information. So the most common way to find the actual yield is to go in the lab and actually do the experiment. So in this case, let's say that that amount that we actually made was 18.5 grams of water. And we want to know what's the percent yield. So again, the formula for percent yield is just how much you actually got divided by the maximum that you could get times 100%. So we actually got 18.5 grams. The best we could have done is 24.71 grams, and that's assuming we don't spill anything in the lab, we don't lose any when we transfer from one container to another, and we assume the chemicals don't react in any other way, which is not always true. So in the lab, you won't always get 100% yield. Many reactions are very low percent yields. And in this case, we get a percent yield just under 75%. So unless you know what the percent yield is, there's no way to find this actual yield on paper. You do that in the lab. Now, if I give you the percent yield and you know the theoretical yield, then mathematically you could solve this equation for the actual yield. That's the other way that you could figure out what the actual yield is. All right, if we put all this together into another problem, we're given the reaction in word form. So this tests a couple of things. Number one, you have to be able to translate the names of the chemicals into their proper formulas, and then you have to balance the equation correctly in order to get the right mole-to-mole ratios. So in this case, we're reacting magnesium solid with oxygen gas. Magnesium is just Mg, and put a little line out in front to change the coefficient. Oxygen, remember, is not O, it's diatomic, it's O2. And then we're forming magnesium oxide. Ionic compound. Magnesium as an ion is +2. Oxide anion's -2. So when you do your crisscross, you get a 2-to-2 ratio that can be simplified to a 1-to-1 ratio. So if you don't get the crisscross correct, you're going to get the wrong formula. And if you have the wrong formula, you may not even be able to balance the equation. If you have a word equation like this that you translate into formulas and it's impossible to balance, double check your original formulas. So if we want to balance this, the magnesium's balanced. We need 2 oxygens, which is going to throw off the magnesium, so I need a coefficient of 2 on the left. Now that we have all of the equation written out, then we can calculate. In this case, we're trying to figure out what's the limiting reactant, what's the theoretical yield, and we were told that we made 11.9 grams of the product. So this would be the actual yield. We want to first figure out what is the theoretical yield. How many grams of magnesium oxide could have come from the 10.1 grams of magnesium. So again, we cannot compare grams of magnesium to grams of magnesium oxide. Anytime you're comparing two chemicals, you have to convert them into moles first. And sometimes the problem will already start you off with moles. So you don't want to use the periodic table to convert it to grams. You're going in the wrong direction. The periodic table, molar mass of magnesium, 24.31 grams per mole. And then the mole-to-mole ratio, moles of magnesium can be turned into moles of magnesium oxide, and this is a 2-to-2 ratio. Notice I could simplify that. 2 to 2 is the same as 1 to 1, but there's no point in simplifying that. If you always remember, use the coefficients, don't ever change them, you're less likely to make a mistake. And then the last step, we want to turn our moles of magnesium oxide into grams. And we use the periodic table again, the molar mass 40.31 grams per mole. So if all the magnesium reacts, we'll make 16.7 grams of magnesium oxide. With the other reactant, we're going to do the same type of calculation. How many grams of the product could come from, in this case we have 10.5 grams of oxygen gas. If we're starting with grams and we want to turn oxygen into magnesium oxide, we first need to use the molar mass from the periodic table to convert grams into moles. Then moles of oxygen can be turned into moles magnesium oxide using the balanced chemical equation, and this is a 1 to 2 ratio. Always write not just moles, write down moles of what the chemical is, because it's very easy to get the 1 to 2 ratio in the wrong order. And then your last step, use the periodic table to turn moles magnesium oxide into grams, and that molar mass 40.31 grams per mole gives us a total of 26.5 grams of the product. If we had a third reactant or a fourth reactant, we would continue and we would do one of these calculations for each reactant. Unless you see excess, then you have to do one calculation like this for every reactant. When you get all the numbers for the product, the theoretical yield is always the smallest. The chemical that runs out, our limiting reactant, has to be the reactant that makes the theoretical yield, which means oxygen is excess. And now we can find the percent yield by taking our actual yield, was given in the problem as 11.9 grams. The theoretical yield was 16.7 grams. Multiply by 100 and you get 71%.